are the future of India. We welcome our co-organizers, SRM College Civil Department, with whom we are conducting a webinar for the second time. Our heartfelt sincere thanks to them and especially to Professor Madhavi. Rope is an article that is in extensive use from cradle to gallows. Steel ropes find innumerable use from bridges to buildings and industrial installations. We do not know the periodicity of the ropes in use. Ropes in use are being tested, and several times they are changed only after accidents. With this lecture, we are confident that there can be an awakening, and we are thankful to Messrs. Aurora Technologies for roping in Dr. Alexander Shilin of Intron to introduce us to test the steel ropes while in service to know its condition. We hope with these few words, again, I welcome you all to the lecture webinar, and thank you one and all. Thank you. Over to Vivek.
Thank you, Sri Ram Prakash, the Chief Advisor of ISNT Chennai Chapter. Thank you for the wonderful welcome address. Now, I would thank Anurag a lot. I just said, Anurag, we need some sort of webinar on wire rope, and he said, okay, fine, I will get you the person. And Alexander Shashlin, he said, Intron is their principal, and we'll have Alexander Shashlin, who's going to give a webinar today. Before giving this one to Alexander Shashlin, I would like to introduce Alexander Shashlin today. Alexander Shashlin is from Moscow, Russia, alma mater, Master of Science in Physics at University College London, dissertation autocorrection of self-pulsing lasers, doctorate at Moscow University of Aviation in Mission Dynamics, dissertations, histories, modeling of mechanical systems with non-stationary oscillations. Worked in Petrofac Limited and worked UK at Safety Group, undertaking quantitative risk assessment for the Karakag Phase 2 project. As a research specialist in Institute of Applied Mechanics, Russian Academy of Science, consulting on extracorporeal sorption system of human Olympic fluid using silicon-coated magnetite particles. At the Institute of Physics, Diagnosis and Modeling, private fund, he was responsible for the design of pressurized test circuit for 4-inch pig. At JSC Electro Story Project, power grid supply and contractor, he was in charge an R&D project on bird protection and interface dampers on 110 and 330 kilowatt pylons. At Intron Plus since 2017, he has level 2 qualification magnetic testing, is primarily responsible for sales and marketing in Middle East, North Africa, Western Europe, has taken part in a number of inspections, including cable trays of Queen Elizabeth II Bridge in London, guy wires at Kuwait and Sarda plants in Kuwait and Saudi Arabia, skylift at Wolan Resort Park near Moscow, and commissioning of Intros auto rope monitoring system on a drilling rig in Stuttgart, Western Siberia. Though his marketing effort, he was able to make Intron a long-term vendor for Saudi Aramco, sell the whole product line up to 150 mm to Saga Subsea, a Norwegian offshore contractor, wrestler away a competitors again, Vertius Crane in the United States of America. Now, the floor is to you, Alexander Shashlin. Please, you can start here, this one. Thank you, Dr. Alexander.
Okay, thank you very much for the introduction. A warm welcome to everybody. It's actually quite a privilege for me to be able to address such a large audience, particularly since when you showed me the videos of your institute. Of course, I remembered my old student days, and one of the dilemmas I had was how to actually implement the academic knowledge into something practical and something that will reach out to a very large community. And of course, non-destructive testing is a prime example of that, where not only are you in a way continuing your knowledge and academic you could say, growth and development of your own self, but also you are helping others on a day-to-day basis. Okay, so as was said, we are Intron Plus. We are Russia's oldest company. Sorry, let me demonstrate. See, can everybody see my screen?
No, Alexander, the screen is not to be seen. You need to share it.
Hold on a second. Hold on a second. What about now?
Yeah, yes, we can see it.
Okay. Okay, so we are Intron Plus. We are Russia's oldest private NDT company. And in addition to the wire ropes, of which you already spoken, we also make systems for non-destructive testing of conveyor belts, tank floors, and pipelines, the pipeline interior gauge. But our, let's see, let's work. Nope, a little here. Okay, okay. But our main credential is our equipment, NDT equipment for wire ropes. So, what is a wire rope? It's a helical structure that's made of steel wires woven around a essential wire, which are in turn make a strand and are woven around a core into the rope. Down here, you could see how they are produced industrially in what we call the cigar machine, which can weave these ropes in kilometers. They come in a range of shapes and sizes. So you can have multi-layered ropes, you can have locked coil ropes, you can have spiral stranded ropes. Each of these have a specific application depending on what the use is. Some will have a fiber core, some will have a metallic core. And of course, they're used these days practically everywhere. So you can have mining, civil engineering, ropeways, guy wires, often onshore cranes, drilling rigs, and many more. But like as was said before, it's a consumable. Now, when we talk about a wire rope, there are two types that I'm gonna, even though they are in parallel, because in terms of structure and in terms of ultimate wear, it all boils down to the same principles. Nonetheless, it's for us, it's very important to segregate between running ropes that you see on lifts and cranes and stationary ropes, like on bridges, on guide structures. So, what's running ropes? Because they are spooled over on drums, and also you have loads on them, you can have damage due to the spooling. You can have fatigue. You can get waviness if it gets overstretched. If it's exposed to the elements, you can have corrosion. You can have heat damage. But for us, all of this damage is manifested in two important and independent parameters. First of all, it's what we call the loss of metallic cross-sectional area, or LMA. This is a quantitative measurement as a percentage of the original metallic cross-sectional area of a new rope. And the second, it's a discrete amount of local faults. These are mainly wire breaks that occur on the rope. By wire breaks, I mean breaks of individual wires during its use for a number of reasons. Now, in stationary ropes, you have the same kind of problem. So obviously, you have axial tension, you have the vibration. All of this causes wires to be in constant contact with each other, and eventually this would lead to nicking. Depending on the environment it's used, you can have corrosion or abrasion due to sandstorms. If it's a flare stack or some kind of industrial application, you can have these actual burnt products themselves release chemicals that will cause a reaction with the steel. And this will cause etch it and further damage it. And finally, there's the human elements. When these ropes are installed, we often see that we can actually see how they were installed because of mishandling. And where for example, a crane would lift the rope, its hook would leave a mark, and this would cause a significant issue in the future. And of course, stationary ropes, running ropes, you have the same problem, LMA and LF due to rope wear. Now, what happens when you leave this all to chance? Well, no, I would not want to be in this cabin. Okay, so to prevent this, obviously ropes need to be looked after. Now, the problem is how to do it. First of all is the visual inspection. Unfortunately, visual inspection is possibly the least practical you can have on ropes. For one, it is very slow. So if you have a rope, a crane that's maybe several up to a kilometer in length, you'll be inspecting it for a while. It's actually very difficult and difficult to organize. You can see the image here below. Oops, sorry about that. Where a rope access person has to slide down the guy wire to be able to inspect it. Ropes often are covered in lubrication, pollution, dust, contaminants, bedding in, and so it's actually very difficult to view the condition of the wires. But the most important is that in a visual inspection, you will only be able to inspect the outer wires. On this X-ray image, you could see how the outer wires look relatively good, whilst inside you already have corrosion setting in and destroying the inner ones. And possibly the most important aspect of this is when you have a rope with visual inspection, you only have these kind of empirical and arbitrary guidelines on how to make an objective conclusion on their condition. And it often happens that a good rope with no wear can be prematurely discarded. And this is actually for many customers, this is a major issue because they have to throw away ropes that have hardly been used just because certain time has passed over since it was purchased. And this is where we come in. We offer equipment that's called magnetic rope testing. Now, the principle of this is that you have a unit that encircles the rope with two annular magnets of opposite polarity. What this does is it completes a magnetic circuit and saturates this section of the rope, causing flux to pass through it. When you have any damage, you will have a bit of leakage of this flux. And the sensors that we use, either it's a pole generator or an induction coil, they will register this flux leakage and convert it into the loss of metallic cross-sectional area. Also, when any sharp defect will also cause a dispersion, and this will be independently measured as a local flaw. And of course, some of the equipment we make. So as I said, what you have is the magnetic head that encircles the rope and a data logger which logs the data. Now, we make units from small 6 millimeters all the way up to 175 millimeters. that you will see in large offshore vessels and bridge cables. So, as I said before, here's what a typical INTROS unit looks like. You have the magnets, you have the sensors, you will have plastic sleeves that will protect you will have an odometer, and you will often have some sort of a system that will stabilize it and centralize it on the rope. So this is what it looks like with a magnetic head on the rope during the inspection. Now, before I get into the equipment, let's talk about the practice in greater detail. Magnetic rope testing, for like any type of NDT, requires two important components. First of all, it's obviously to have the equipment. And by equipment, even though it's a relatively new practice, it's already one that's been institutionalized. So you can see four standards, which I will go into greater detail, and mainly that it has to saturate the rope. It has to see the inner broken wires, and that the testing of data has to be repeatable. What that means is that if someone else was to test the same rope at a later time, the results have to be coherent with each other. The second aspect is obviously the people doing the inspection. So obviously, some sort of qualification, a general qualification in non-destructive testing, like level 2, maybe level 3, but also because it's a very specific type of equipment, we insist that people have training, and we also offer training to our customers. And also, of course, with training, you need experience. So people who have continuous practice with MRT are particularly important, especially on very non-standard kind of applications. So in terms of standards, as I said, first of all, you have the ASTM standard on electromagnetic testing, the ISO 4309 on crane ropes, you have the Euro norms on the ropeways, the IMC, the IMCA on offshore, and also many national and internal company policies that have been introduced, where in certain matters where these standards may or may not cover. Now, of these standards, why did I say magnetic saturation? Well, Intron is not the only producer of NDT technology, but it's the only producer that insists that its equipment must saturate the rope, must magnetize the rope to saturation. Why is this? Here you see a hysteresis curve. If it's not saturated, your results will be somewhere over here, which can be ambiguous. When saturated, it will be right on the edge, and you will clearly know that this is an error, not some noise, not some anomalous signal. And here's what you can have. For an external wire break, you will have a clear signal, but on a weakly magnetized, on a weakly magnetized, you will also have a clear signal. But when it comes to an internal break, we will still see the wire break clearly. But for weak magnetization, all you will see is noise. So here are some examples of how we use our MRT for offshore ropes. As I said, we have smaller units, bigger units. If you think that some of these ropes can cost over $1 million US, then it's a huge investment for them, for the companies, to actually purchase this kind of equipment or this kind of service. Ropeways. Now, when I said about standards, I specifically said about conformity and the Euro norms. Now, of all the standards, this is actually the most strictest, because for ropeways, obviously they carry people. And the standard is to be able to detect a broken wire in the core. So far, in 2018, we've sent 2 of our units to Italy, to the LATIF laboratory. And so far, we know we were the only ones to be able to actually pass this requirement. And inspection of spare ropes. So usually guy wires, like on antenna masts and on bridges. For sometimes, for example, for flare stacks where it may not be possible to run the magnetic head, we use a climber unit to mechanically be able to not mechanically, robotically be able to inspect the rope. So let me run you through a typical inspection. First of all, you need to prepare the equipment. By this, obviously, selecting the magnetic head suitable for the rope diameter, installing the necessary sensors and plastic sleeves, and to calibrate the unit. Now, for calibration, you need 2 reference points. So either you take the first reference point of a rope without a defect, and end of a section where you know the value of the defect. So you can count the amount of broken wires, and you can mathematically deduce what is the percentage LMA. Sometimes, when you don't have this opportunity, particularly on the bigger ropes, you can actually tape a piece of rope or a piece of wire onto the surface and use the negative LMA as a reference point. And possibly the most common one is you can simply take the unit off the rope and enter 100% LMA, and you're on your way. The LF signal is actually discrete, so it doesn't require any calibration, but with our equipment, it will make data analysis a lot easier if you actually set the thresholds at what point it should consider a broken wire. Now, for running ropes, for running ropes, once you've calibrated it, you'll need to attach obviously install it on the rope, anchor it, input a reference 0 point, and then run the rope twice its length. The first run, you will actually magnetize the rope, and on the reverse run, you will measure it. For the stationary ropes, same principle. You'd input the 0 point, you'd install, and then you'd also connect to either a climber unit or to a winch, which will articulate the magnetic head up and down the rope. Next, you will record it. So on the ascent, you will magnetize the rope, and on the descent, you will actually be your measurements. And then, obviously, is the data analysis and the report. Now, with data analysis, it is a particularly important science in its own right. Because, for example, here, you have a rope that's been exposed to severe wear and corrosion. Actually, right here, with 17% LMA indicates you have a broken core. And here you have a very corroded piece. And of course, on the LF signal, all you see is noise. But when you have individual wire breaks, you see very, very clearly pronounced. Now, it's actually, what's interesting here is that there are actually 3 wire breaks, 1 here and 2 here, because the signal is double. But because they're located exactly parallel to each other, the signal has been superimposed. Next, the discard criteria. Now, different standards establish different discard criteria. But if we use the ISO and the IMCA as a reference, what they do is they say what is the maximum amount of wire breaks, or quantitatively the LMA, over a unit length. So over 6D, 6 times the rope diameter, and 30. And what you see here are two mutually exclusive cases where you have rope discard. So for example, on a 6D length, you have only 4%, which means it's fine. But over 30D, you have a total of 10%, which means the rope must be discarded. Whilst here, on 30D, you have only 6%, which means it's used. But because this 6% is concentrated in a 6D region, it still must be discarded. The reason why this is done so is because after a certain, even if you have a wire break, after a certain length, it will actually, because it's very tightly woven, it will actually regain its load-bearing capacity. But obviously, this can happen only to a certain extent. Now, since I was told that this conference is about bridges, so I will actually show you a case, an interesting case study we've had regarding inspection of bridges. Over the years, we've inspected a number of them, mostly in Russia, but also in the United Kingdom, where I was present, and in Korea. Let me give you a video. I hope this works, because I've sped it up 5 times just to save you the trouble of watching how 2 Russian guys turn some nuts and bolts. So what they did, what they're doing here they're installing it. They've installed it on the rope, connected all the cables. Here we've hooked up the hoist line, hooked up the return sling, and off it goes. So this is the ascent. We're magnetizing the rope, and now we're actually doing the measurements as it's coming down. And that's actually, if you noticed, the setup is very, very quick in terms of inspection of ropes. But even on a large unit like this is a 6085 magnetic head. You normally would take about 20 minutes, because this obviously is sped up to do one rope and then the next one. I think they did the whole bridge in about a week. So anyway, one of the first bridges that we've done was actually a Yugorsky bridge located in the north of Russia. It's a cable-stayed type of bridge with the spiral stranded types of ropes. And what you can see here is that some of the ropes, some of the wires began to become displaced from their lock. Now, we measured this, found that the LMA here, the LMA is actually negative because you have a local increase in diameter. But you can also see on the wire breaks that they exist. And ultimately, the customer took emergency measures to prevent this kind of damage from spreading. We've re-inspected the bridge 10 years later. So the first image was from 2009. This is 2019. And even though obviously this was, well, we couldn't stop this, but the rest of the cable there's no deterioration since then. So obviously the customer had a very huge relief that he did not have to replace a cable, and you can imagine how much it cost them. Now here, as a little bonus for you, for this kind of, I'm actually going to share with you one of our research projects that we're undertaking right now. Now, one of the most places, whenever you have a stationary rope, or that possibly is the most concern, is the termination. And the reason why is because when the rope is embedded into the termination, you will actually have molten metal poured being poured in there. And this process, obviously, it damages the galvanic protection covering on the wires. And this causes premature corrosion. What's more is because this point of contact, if the rope is not perfectly straight, it's under extreme amount of articulations. It acts like a joint. So yeah, so the wires in this section are the most stressed. Now, in terms of current standards, you know, it says, I read it as it says, difficult, if not impossible, to detect flaws at or near rope termination and ferromagnetic steel connections. Why is this? Because this is a huge piece of steel which will disrupt the signal. On the trace here, you can actually see the influence, how the LMA spikes in this region, which is why you can't really make any measurement, any quantitative measurement here. Or so the standards say, because we are able to take measurements of the section. So how do we do it? When the magnetic head approaches the termination, you will have flux enter the termination. Now, if the magnitude of this will be constant, now the magnitude of this influence will actually be constant when the magnetic head is stationary. But if the rope is in a bad condition here, this will generate additional flux leakage. So if you have a calibration curve, i.e., if you know the value of the influence this has, you know, you could simply just subtract one from the other and determine it. So what I'm saying here is that you have a calibration trace, you have a flawless rope in an identical termination, and then you have your real inspection data. We have a conversion factor, which inverts and amplifies the signal. And once this is combined, what you have is, for example, and appended to the results. On a good rope, you will see the LMA decrease. And this is expected because you subtract it. But on a worn rope, even though you have damage here, look here, this is the 0 point is actually off the scale, and it's still positive LMA, which means there's damage in this region. Now, why did I say it's a research project? Because obviously it's a method that can be done only if you have a calibration curve with an existing termination. But what we are actually doing right now is finding out, well, not finding out, we're actually testing a system that will kind of cover the termination a little bit. And not only will this allow you to have a method that will make the calibration curves and all these conversion factor issues obsolete, you will actually see that section of the rope inside the termination and what its condition is. So something to look forward to in the near future from us. Now, another thing that I wanted to show you is that, okay, so you have some data, but how do you, is there a possibility, how can you forecast a rope? Obviously, you can take repeated traces over a set period of time, but still, it's to be able from this kind of data, even though you're seeing that the rope is beginning to become more and more worn, to be able to tell a customer when to discard the rope, something else is required. Now, what we do is we actually take into account, we have an in-house calculation where we take into account the tension of the rope, if it's an outside rope, if it's a stay rope, we take the wind factors, the age, the construction, and we calculate the load bearing capacity for each wires, for both a new rope, what it should be, and the critical value at what it be when it's failed. So here is a length of rope with damage, and you can see here's the worst case scenario, where the safety factor is roughly 3/4 between a good new rope and a critical state. And what we do is we take this worst case value and we plot it over the years when we take repeated measurements of this rope. So here you can see it's starting to degrade, and from this you can actually forecast, after several measurements over a set period of time, you can forecast when the rope is going to fail. Okay, before I wrap this up, a little reference, how to say, to our work in India. So we've been, first of all, obviously to our agents, Aurora Technologies. You know, we've been operating for nearly 10 years now. We've made sales to many important customers, such as Tata Steel, Hindustan Aeronautics, Hindalco, and so on. You can see the logos. But also, you can see here that MRT itself is starting to become institutionalized in India by with national standards being released. And of course, just to give you a scale of where we are globally, here's some of the customers that we've made sales to over the years. You can see, obviously, for me, a matter of pride is Saudi Aramco, where I personally kind of broke the wall to them, but also many other. For example, for Koni cranes, we actually make specific equipment to their standard. So that's a wrap. I think that's it. Any questions?
Yeah. Thank you, Alexander. It was a fantastic interview of the complete wire rope session and taken to wide aspects. We have gone through wire rope, where it can be used, where the wire ropes can be tested. Any questions to Alexander here from the participants?
Yeah, you can type your questions in the chat box. It's enabled now.
Alexander, the first question is from Dr. G. Raghav. Are there minimum and maximum speed values with which the instruments can traverse along the rope during inspection? And his next question is, how was the strength safety factor regression forecast for the rope carried out?
Okay, in terms of the first question, our equipment can right now measure up to 4 meters per second, which is really a fantastic speed, because applications rarely even run ropes at that speed. Obviously, beyond that, what you will have is you will still have the measurements taken, but because it's a factor of the odometer wheel limitation factor, really. You will still have the measurement taken, but in terms of their distance and their actual reference points, they can become corrupted. Okay, for the second question, how is the strength safety factor forecast carried out? What we do is we take a rope and we look at its component wires. And first of all, we calculate the safety factor of what it'd be for an ideal rope. So there is obviously you have the stress factor of the steel itself, the wires as a helical structure, and then the length of the rope. And then once you have that, we have the magnetic rope testing results. So we know how many broken wires there are on a certain space, and we calculate how much the load-bearing capacity has been lost in that section of where the rope has been broken. And then from that we convert it into the safety factor. It's covered in literature. It's in the industrial standard, because if you have a new rope and the low rope and the damaged rope, then you can use those two as reference values. Okay.
Yeah. Thank you, Dr. Alexander. The next question is, how to prevent rope corrosion?
Well, it's not really a question to us, it's a question
I
to
know
the,
that, yes.
the operation, but obviously lubrication is the number one inhibitor corrosion, because obviously if moisture can't penetrate into the wires, you know, it's not going to cause anything. But in reality, it's kind of an issue that sometimes even lubrication can't save the rope, because once, particularly if there's an ingress point somewhere inside the rope, like in the termination, for example, and water, it has this kind of tendency of finding its way into any small cavity, and once it's in there, it will begin, you know, digging out. So what you, in terms of preventing, but you can certainly manage it by inspecting. Okay.
The next question is this stationary testing?
In terms of what do you mean in terms of stationary?
He's saying there is the instrument stationary or the wire, something which is stationary, like.
But it can be both. Well, if the wire is stationary, the instrument has to move up and down the wire, like on a bridge.
Yes.
If the rope, if it's a running rope, then it's the opposite. The instrument is anchored, and the rope is run through the instrument.
Yes, Dr. Alexander, we have our Dean of SRM University, who's going to give a small address by the Dean, Dr. Murali Krishnan. Sir, it's on you, sir. Dr. Murali Krishnan, sir.
Yes, sir. Thank you, sir. Very good afternoon to everybody present here in this online session. The Honorable Chief Guest, Dr. Alexander, Intron plus Russia. I am felt very happy that the Department of Civil Engineering has conducted an international webinar on in situ testing of wire ropes used in suspension bridges and other installations. I felt very happy to see the number of participants are crossed than more than 300 plus. So that shows that actually the importance of this today's session about our speaker. I've been interacting with this meeting for a long time, and I will felt very happy that there are a lot of interaction with the participants. And particularly today, the topic is a very advanced topic. Somebody will say that about the civil engineering, and I can say that a lot of developments are there in the civil engineering because of the latest technologies. So I used to inform my students and as well as my faculty members and all. Now at present, actually the industry, the world is looking for the best civil engineers. The technology has come into not in the IT sector, the technology has come in the infrastructure. So everywhere without infrastructure, we cannot live. The software may be help in one side, but the other side, everybody needs comfort. Maybe in the form of a whatever it may be. I'm able to see the latest developments in the civil engineering. You take about any national highways, take about any metro rail, anywhere you need a civil engineering. So these type of suspension bridges, I happened to see recently in Hyderabad, they have been constructed a very small one, in the small, a small river where they constructed. Now you see actually it is a beautiful idea, beautiful design. They made it in such a way that it is very, very comfortable compared with the other bridges. I once again thank you very much, Mr. Alexander sir, for interacting with our faculty members and our members. And we have been tied up with this particular association, Indian Society for Non-Destructive Testing. They have been counterpart of SRMRMP Ramapuram Chennai campus. They have been conducting regular interviews webinars. And this is the only one webinar. Whenever they conduct, the number of participants will be more than 300, 400, 500 plus. That shows that actually the quality of the program. In engineering, like in IT, other sectors, if you conduct maybe maximum 50, 100, that's all, because everybody say busy, busy, busy. But this program, the success has come into the picture. I'll appreciate the department. I'll appreciate the Society of Non-Destructive Testing, etc., for conducting this wonderful webinar on these latest developments in the civil engineering. My sincere request to the Society of Non-Destructive Testing, please kindly provide me a few opportunities to our department, our students, our faculty members to enhance their skills. Thank you, Vananda sir, for giving this opportunity.
Yeah. Thank you, Dr. Muralikrishnan, Dean of SRM. Thank you very much for your valuable time and valuable inputs. Thank you very much, sir. So shall we go ahead with our question and answer sessions? Dr. Madhavi?
Yes, sir. Yeah. And I would also thank our dean for his presence. He was
No, madam, there is no
Yes,
thanks. It is my duty. Don't say thanks.
You have been very supportive for us.
No.
Yes,
It is my duty. I am very happy.
Yes, thank you, sir. Thank you very much. Yes, Mr. Vivek, we can proceed ahead with the further questions.
Yeah, we shall. Is that the next question is from Bhavati Parmal? Is there any inline testing method?
You mean by inline? You mean to be able to invert the unit?
Mr. Bhagwati Parmal, just can you switch on your mic and ask us clarification, please? Because it just says, is there an inline testing method? We need to know something more about it. Okay, I think so. We'll take the next question. What are the methodology used for arranging the inspection? The next question is.
Well, the methodology it's generated from science, really, because to be able to record the rope, you need to record the whole length. So this is when we began this business originally in late 1990s. Is that actually the story of our unit was that we began. It was a research project for mining hoists because they had several accidents in north of Russia where they had some ruptures. So they wanted a system that could be able to measure the integrity. And before that, ropes, there were some equipment that could measure the surface wires using electromagnetic testing. But it was really our idea, because our company was founded by several professors from the Moscow Institute of Power Engineering, so for power lines and energy. And they were the ones who suggested that we magnetize the rope to saturation. And if we magnetize the rope to saturation, then we can then the flux leakage that we'll have from damage will actually be proportional to the damage. And after when it found out that it was actually dead on and dead accurate, this is really where we realized that we've struck a gold mine. And within several years, we were making, rope manufacturers were coming to us to ask for using our equipment for quality control. Actually, Usha Martin in India is one such unit that does this. So in terms of methodology, overall, as I said in my talk, the principle is the same for just about any rope, that you need to run the whole length and record this data. Now, ideally, you need 2 runs, because for the first run, you will be magnetizing it. On the reverse run, you will actually be doing the measurements on a magnetized rope. If you can't have 2 runs, because sometimes for whatever reason they won't give you the second run, you will still have the data. The LF signal will still be true because it's dispersions that are caused by wires. The LMA will have some sort of a measurement error, but in terms of serious wire breaks, you will still see them. But in terms of smaller wire breaks, then you come to this the situation which I talked about on saturation, where you have weak magnetization, and you may not be able to distinguish smaller defects from noise. So I think that answers the question about methodology.
Yeah. Thank you, Dr. Alexander. The next question is from Mr. Anil Mankar. He says, what's the scope of wire testing in India?
Well, I would really like to pass this question to Aurora.
Yeah, I will answer. If Anurag is there, Anurag will answer, or I can answer, because there's a huge.
Just missed it. Yeah.
Yeah, Anurag, they say what's the scope of wire testing in India? I think there's a huge demand for that in India. You can just go ahead.
Yes. So no, first of all, that's a nice question.
Yeah.
Now, yes, wire rope testing has a huge demand in India, considering the amount of ports that are under development right now, the kind of cranes that are used in ports. That's one area where we can work at. Even as Alexander Wright mentioned, we have now 2 of these standards in the country where they are clearly mentioning about those the importance of magnetic rope testing. So yes, India is working on that in that area, and we have a good scope both in steel industry, we have in mining industry, we have in the ports or what I call cableways, ropeways. We have there even in the manufacturing plants. Nowadays, due to heated conditions, the wire ropes can have a loss of metallic area. So there also we have a huge scope. So yes, this testing has a huge scope in India, and there are a lot of places where it is yet to be implemented, and we are definitely working on that. Yes.
Yeah. Thank you, Anurag. Thank you very much. The next question is from Shanmugam Sundaram. Is there any predominant variation in interpreting of running and stay wire ropes?
In terms of the actual interpretation of data, not really. But obviously there are particularities regarding because the defects that we look for will be different due to their nature. So a good example would be, for example, is that on a running rope, you would expect to see a lot of individual wire breaks. For example, if it's an indoor facility, if it's a stress or fatigue or stress, and also you will see abrasion due to the crushing. This will have a distinct characteristic on the signal. On a stay rope, we expect to see primarily, obviously, age-related wear, and also internal wire breaks due to the axial load and the vibration. So again, they will have their own characteristic sign. But in terms of the actual method, it's the same thing. The person is going to sit there and look through the charts. The software will obviously aid him in terms of how to filter it, how to reference it. But in terms of actual variation, really, it's the same kind of approach.
Okay. The next question is from Manish Singhal. I don't know how does this come here. What is tensile strength of ropes? What is tensile strength of strands?
See, what is tensile strength of ropes? It depends on the rope, because every rope manufacturer will have a specification.
That's right.
So it's really, it's right now off the top of my head, I can't remember what are the boundaries, but every rope will have kind of the an indication of what they call it, the minimal breaking strength. That is how they're graded. So at what point you will actually see the rope snap, fail when it's overloaded, and that is what we used as a guideline for designing the machinery or the building And of course, regarding ropes and strands, then if it's normally what we'd expect, if it's a stranded rope, then each strand will equally carry the load-bearing capacity of the rope. So if on a common IWRC 636 rope, where you have 6 strands around a fiber core, and obviously each strand will be 1/6 of the rope's value.
Right. Thank you, Alexander. The next question from Danyandran: which softwares were used in numerical inspection?
We produce with our equipment. We offer our own software called Vintros. It allows to do quite a number of functions of how to actually interpret the data. Also, we have a software which allows to view the inspection in real time. And actually, here's a little comical history to go with this, is that when we started making sales abroad, even though this was like late 1990s, early 2000s, we had a customer saying, well, to record, you need to have this kind of a graph, this thing that writes the graph so you can have a look. And we said, look, we've digitalized this. And this is a company, this was a very big Western European company. We're still insisting on graphs where we are all digitalized. So, yeah, but the answer is Vintros.
Our very next interesting question is from Bhavani Prasad. Is there any diameter limit for the equipment? So what shall be the maximum diameter of wire rope it can hold?
175 millimeters is the biggest we make, is our flagship model, from 100 to 175 millimeters. These are again the bridges and for the offshore ropes that you have for the deep sea construction and exploration. The reason we could hypothetically make bigger, but because we have permanent magnets, you have the issue of weight. So the 175 unit, its shipping weight alone is 400 kilograms. And it takes 4 people to install that unit on the rope. You do it one at a time. You have straps. It's quite a challenge in its own right.
Okay, so the maximum is 175. So what do people do if it's beyond 175? So they don't do they do some sort of testing, or is it going to be the visual inspection?
Well, the thing is, beyond 175, we never had actually a customer with that.
Okay.
Because if you think about size-wise, the biggest wire rope right now that we know of is 168 millimeters. It's used on a Saipan vessel, one of our customers. Obviously, you have the main cables for the suspension bridges, but how would you inspect that? Because to inspect that, you have the suspension ropes, so you have to move the suspension ropes to be able to inspect that. Normally, on those kind of cases, you would actually be able to, you will not need magnetic rope testing to be able to see what is the condition of those ropes, because of the component wires themselves will be very big, and you can actually look inside the rope to be able to see that. But also for this, remember the question is about wire ropes, right? We also make a unit for parallel stranded ropes, which means ropes that are not made by wires, but out of parallel strands, individual. It's like it's encased in a matrix. Now, we have a unit that goes up to 300 millimeters for this. And in terms of bridges, many of them actually use this. It's pioneered by a French company called Freyssinet. And so, it's the reason why we can make up to 300 millimeters because we use an electromagnetic tester, and because the discard is not individual broken wires in the strands, but actually the ruptures of the strands themselves. So they'll be able to register the ruptures, but not the quantitative LMA. Okay.
Dr. Alexander, the last question, and very interesting from Srikanth here. Do you think the digital twins and current sensor technology can help for continuous and automatic monitoring of rope health in real time? Very interesting question. It's from Srikanth.
Okay. It's a very good question, because we have a system that actually based on our Intros equipment, which we call Intros Auto, which is made for this very purpose. It's made to monitor high integrity, high value ropes. It began for drilling rigs, and then now it's gaining its introduction into various other industries. The way it works is that the discard criteria itself, it's actually programmed into the system. So effectively, there's no need to actually analyze the data, because the system automatically does that for you. So effectively, if you have like a crane operator in his cabin, he pushes 2 buttons and immediately sees what is the condition of his rope. And obviously, as it approaches the discard criteria, you'll have a warning light, and then you have like a red alarm signal saying that discard your rope. Now, it's actually, in terms of the first part of this question, how to integrate this. We have a steel mill in Russia where the wire ropes are used to tip the ladle bucket that pours the steel into the blast furnace, the iron into the blast furnace. Sorry about that. Now, obviously, you can imagine the conditions. You have hot metal, you have explosions of going there, and so what they did initially, they had a limit, an empirical limit of 1,200 pouring cycles. After this, the rope must be discarded. When they installed our system, we found that normally at 1,200 pouring cycles, the value of the LMA was below the 6% of the 6% that they specified in their guidelines. So we told them, okay,